Hello, it's Leanne Horbrick, and I want to talk to you about dimensional analysis. Dimensional analysis is sometimes called conversion factors, so that's what we're going to work on right now. And see if I can get this to move. So, in order to do this, you need to know what rates and unit rates are. So a rate is basically a ratio that compares two quantities with different units. For example, 24 pencils cost $1.20. So the two units are pencils and dollars for money. If you wanted to know the price per pencil, that would be a unit race. The word unit means one or per one. So on this example, it says unit rate is a rate that has one as the denominator. So if I wanted the price per pencil, I would need to have the pencil in the denominator and the price on top. And if you look here, I do. The dollar bill is on top and the 24 pencils are on bottom. In the calculator, I just have to put $1.20 divided by 24 pencils. In essence, what we're really doing is dividing them both by the same number, so we're not changing it at all, because anything divided by itself is 1. So we're left with 5 cents per pencil. So I can write it as 0.05 slash pencil, or 5 cents per pencil, and now I have a unit race. What if I wanted to know how many pencils I could purchase with $1? Well, I would put the dollar now in the denominator and the pencils on top. And now I divide the 24 by the $1.20. 24 divided by $1.20 means I can get 20 pencils for $1, 20 pencils per dollar. So now it's a unit rate. Sometimes you're going to need to know the conversion factors. So if we look at this next one coming up, we know that 1 mile is 1.60934 kilometers, and 60 minutes is 1 hour. In this case, we're given 50 kilometers per hour. If you were driving at a rate of 50 kilometers per hour, how fast are you going in miles per minute? So miles per minute is what we are looking for. So I want to end up with miles on top and minute on bottom. I'm starting out with kilometers on top and hours on bottom. We have two conversion factors here. To get rid of the kilometers on top, I need this unit to cancel out with kilometers on bottom. So I take this conversion factor, I put the 1 mile on top and the 1.60934 kilometers on bottom. Use multiplication for each, because basically all we're doing is multiplying fractions. Now I want to have minute on bottom. So I need to get the 60 minutes on bottom and the hour on top. The hour on bottom here will cancel out the hour here. And then I'm left with the numerator would be 50 times 1 times 1. The denominator would be 1.60934 times 60. How I put this in a calculator is I do my whole top. 50 times 1 times 1 divide by, and I open parentheses, 1.6093 times 4, 1.60934 times 60, close parentheses, equal, and you will end up with a half a mile per minute. Good. So this next one gives you the directions in two formats. One, write the given values, the starting and the ending. In the example here, we're asked to convert 24 kilometers per minute into meters per second. So we're given 24 kilometers per minute. This is the given. We want to end up with meters per second. This is the symbol for meters per second right here. So I want these to stay, and I have to look at what the conversion factors are. Sometimes you're expected to know it. Kilo means 1,000. There are 1,000 meters in 1 kilometer. There are 1,000 meters in 1 kilometer. Since the kilometer was on top, I need the kilometer to be on bottom, so these units will cancel out. Now we have to get to minute per second. It's understood, hopefully, that you know there are 60 minutes in 1 second. There are 60 minutes in 1 second. We want the second to be on bottom, so I need the second to end up on bottom. I need the minute on bottom here and on top here so that they will cancel. You can only cancel a numerator with a denominator. Simply do 24 times 1,000 and you get 24,000. Divide 24,000 by 60 and you are left with 400. The only units still not crossed out are meters and seconds. So 24 kilometers per minute is the same as 40 meters per second. Here's another way to look at it, how to set it up. The units you have, start with the units you're given. The unit you want is what has to end up on the right side of the equal sign. So the unit you have is what you're starting out with. That's going to basically be your numerator over 1. They have to cancel out. So you want the unit you have to end up on bottom, the unit you want to end up in your numerator, so that's what you're left over with. Okay, so here we're given, you walk into a post office or a postal shipping area, and they give you these charts for shipping. And as you look on this chart, 3 to 5 days is 49 cents per pound. 2 days is 89 cents per pound, and 1 day is $1.89 per pound. So the first time you go in and you want to order a 330-pound weight set. That's what you're given, a 330-pound weight set. And you want to use the 2-day shipping. What is the shipping fee? So start with your 330 pounds on the top. That's the unit you're given. Then you have to look up the price. The price for 2 days is 89 cents per pound. This is the unit conversion right here, the 89 cents per pound. We want the pounds to cancel out because we're looking for cost. We need the dollar bill on top. So we're going to cross out the pounds, and the only unit we're left with is the dollar sign. 300 times 89 cents is going to give us $293.70. Always make sure to answer your question in a complete sentence. It will cost $293.70 to ship the weight set. What if I want to order a 119-pound couch? And I'm not sure if I want to pay the shipping for the 1 day, or should I just have it delivered in 3 to 5 days? So for me, I want to determine what is the difference. How much more will I pay to have it in just 1 day? So, well, in order to do this, I would have to figure out the cost for 1 day first. So I'm given 119, so I'm going to start with 119 pounds on top. Look at the 1 day shipping. It is 89 cents per pound. So I need the money on top and the pound on bottom. So the 1 day shipping, 119 pounds is given, dollar bill over pounds, cancel out those pounds. Oop, that should have been up there. And then just multiply it out, and you're left with $224.91. Well, let's see what the 3 day shipping is. The 3 days is only 49 cents a pound. Make sure the units are going to cancel out. I think my units are off a little, my things. I'll have to fix that later. But it's $58. So To get this in 3 to 5 days, I only pay 58. To get it the next day is 224. Well, what's the difference? Is this something I'm willing to pay? I would have to subtract the two. Am I really willing to pay an extra $166.60? It's $166.60 underneath that picture. Okay, let's look at another situation. I'm going to try to go through 8 examples. You recently purchased a pair of headphones online. The shipping fee was $12.24. You believe that you were overcharged for the 3 to 5 day shipping, but the weight of the headphones is not listed on the receipt. How much do the headphones have to weigh for this fee to be correct? So we know the final price was $12.24, and the 3 to 5 day shipping is 49 cents per pound. So let's set up a ratio. Let's set up what we have. We know that, why isn't it moving? It was $12.24, and then it's 49 cents per pound. So this is going to get us to the weight. So I want to cancel out the money and get to weight. So the dollar signs are now canceled, and I am left with 224 pounds divided by 49. The only thing still left are the pounds. So the weight of the headphones, by using this dimensional analysis, comes to 24.98 pounds. That's basically 25 pounds. Do you use headphones that weigh 25 pounds? So now answer the question. It's not reasonable. A pair of headphones does not weigh 25 pounds. So this would be unrealistic. Let's look at another one. The green road signs that you see as you're driving? This one says it's 26 miles to Santa Barbara, 54 to Ventura, 122 to Los Angeles. Let's figure out how long it would take to drive to Ventura if we're driving at a constant rate of 45 miles per hour. So we know we're traveling at 45 miles per hour. We want to drive to Ventura, which is 54 miles. Notice Ventura is 54 miles. This is the given. The 54 miles is the given. Our conversion is the 45 miles per hour. And we want to be left with time because how long will it take? So start with the 54 miles. 1 hour and 45 miles. That's the rate we're driving. The miles had to go on bottom, so we're left with hours. Cross out the miles, and you're left with 54 hours divided by 45 gives you 1.2 hours. So 1.2 hours or 72 miles is how long it'll take to drive to Ventura. I do have the full sentence there, it's just covered. If you wanted to do a separate conversion and get put the light on, the resulting units in minutes, I could have taken the 54 miles divided by the unit rate of 1 hour and 45 miles. That's the rate I was driving, 60 minutes per hour. I need to get the miles to cancel, the hours to cancel, multiply the numerators by the denominator. I wonder if I can move this picture up out of the way. So the miles have canceled. So this is our rate. This is the conversion factor that you're expected to know. The minutes will cancel, and you're left with 72 minutes. So 1.2 hours is 72 minutes. All right, what about if we go to Los Angeles? LA is 122 miles, and now we're driving at 65 miles. So 122 is our goal. The rate is 1 hour and 65 miles, or 65 miles per hour. Cancel out the miles so we can be left with hours, and we're left with 1.88 hours. And it's okay, just leave it like that. Don't do more work than necessary. Okay, so this is an EKG from the very tip of one to the tip of the other would be considered one beat. Let's look at what they tell us here. A human heart weighs 10 ounces. On average, it beats 70 times per minute. That's on average, 70 times per minute, and pumps about 2.5 fluid ounces of blood with each beat. What is the heart rate of the person whose EKG is shown? Is this normal? So there's a little scale on the bottom. 1, 2, 3, 4, 5. 5 seconds, 5 boxes is 0.2 seconds. 2/10 of a second is 5 boxes. And from here to here is 20 boxes. So let's use that information. One beat from here to here took 20 squares, 20 boxes. The rate here shows me that 5 of these squares is 2/10 of a second. So the first thing I can determine is the beats per second. I can do this in one shot or in two. Let's get rid of the squares, and we're left with 1.25 beats per second. But notice this is given in times per minute. So now I have to get rid of the seconds and get to minutes. I could have just put another multiplication in here and have done this in one problem. But if I take the 125 beats per second, I know there's 60 seconds to a minute. I want the seconds to be gone, and I want to be left with beats per minute. So at this rate, when the seconds cancel out, I'm left with 75 beats per minute. That's pretty close to 70 beats per minute. So this would be within normal range. Notice that the squares and the seconds are canceled out. Okay, let's say a person's going to drive at a constant speed of 75 miles per hour for 2.8 hours. How many total miles will the person have driven? Now it says, show your work using dimensional analysis. I know we can do this without using dimensional analysis, but I'm going to use the dimensional analysis for this question. We have a rate of 75 miles for 2.8 hours. And we want to know the total miles driven. So start with that rate. Start with the 75 miles per hour for 2.8 hours. So this rate here, 75 miles per hour, 75 miles per hour, 2.8 hours. This is going to allow our hours to cancel. And we will end up with 210 miles. Now, could you have just multiplied these and know that the hours canceled out? Yes. Make sure you answer with a full sentence. The person drove a total of 210 miles, driving at a constant rate of 75 miles per hour. Okay, let's look at this one. How long does it take a person to drive 6.3 miles? So now we're looking for time. How long does it take a person to drive 6.3 miles at a constant rate of 45 miles per hour. Again, we could do this without dimensional analysis, but it said to use it. So we're given the 6.3 miles and the rate is 45 miles per hour. I want the miles to cancel. So I may have to make sure one's in the numerator, one's in the denominator. And once the miles cancel, I am left with 6.3 hours times 1 divided by 45. I'm missing my hours on here. This should say 6.3 hours. And you get 0.14 hours. I'll have to fix that. So it'll take 0.14 of an hour to drive 6.3 miles at a constant rate. So I hope you find this helpful.